Hi, we are Group 70, comprising Shoaib Ali Mir, Ritankar De, Somnath Paul, Rituparna Pal, and Shumala Mukhopadhyay. Each team member contributed equally with a 20% contribution towards the design, development, testing, documentation, and presentation of this project. For this assignment, we have developed a cloud native machine learning pipeline that demonstrates the complete life cycle of a data science application. The project covers data ingestion, pre processing, EDA, machine learning, MLOps, monitoring, and API driven application access. Our solution leverages Amazon S3 as the cloud data lake, AWS Glue for data pre-processing and EDA, AWS Lambda and Amazon Event Bridge for orchestration and scheduling, Amazon CloudWatch for centralized logging and monitoring, Amazon SageMaker MLflow for experiment tracking and model management, and REST APIs to expose application details through a custom dashboard. Together, these components form an automated, scalable, and cloud native machine learning workflow that satisfies all the requirements of the assignment. This is the ingestion side of the pipeline, a plain Python script that simulates a new batch of patient records arriving. I'm going to push one batch in manually to trigger the whole end-to-end thing. This uploads the batch to a time-stamped S3 partition, that is raw heart disease and the date timestamp, and confirms the upload actually landed before it moves on, rather than assuming the S3 call succeeded. Every step in this pipeline logs structured JSON, not free text like bucket, key, size, status, timing. That's deliberate. It's what lets the dashboard later parse pipeline history straight out of CloudWatch logs, and it's exactly the kind of ingestion logging the assignment calls for. Here's the landing zone in the console. Each folder is one batch arrival timestamped, so nothing overwrites anything, and the pipeline can tell new batches apart from ones it's already processed. Pre-processing runs on Glue Python shell, not Spark. That is because at this data volume, Spark's cold start alone could blow past a tight processing window, and it costs a fraction as much in this approach. Every run here succeeded, and you can see actual durations, not estimates. Every glue run logs to CloudWatch automatically. Here's the job pulling its own pre processing script from S3 at startup. And here's the substance what got imputed, how categoricals were encoded, the shape of both the human readable clean dataset and the scaled one hot machine learning ready dataset. It hands off to training. This is the pre processing and missing value handling the assignment asks for. This is the dashboard polling a REST API, not reading static files. Logistic regression and random forests are trained on a 70-30 split every run. And here are 5 separate metrics compared side by side, which is more than the assignment's minimum bar. Their importance and the correlation heat map come straight out of the EDA step, regenerated, fresh every run. The pipeline runs panel is reading the orchestration layer's own CloudWatch logs, 42 runs and counting, so the dashboard covers both the ML tracking side and the execution side, not just one or the other. The orchestration itself is a Lambda on an event bridge schedule. No server for anyone to patch, and everything it does is captured here. The dashboard talks to a proxy Lambda. which is the piece that actually signs requests to MLflow and reads CloudWatch on the dashboard's behalf. A browser can't do AWS request signing on its own. And this is the actual MLflow experiment tracking UI, not just the dashboard's summary of it. It has the full run details, metrics, and parameters served by SageMaker's managed tracking server. Whatever we are seeing here is everything the pipeline and the proxy logs about talking to MLflow. We are not using traces for this project. The only things we are logging are the model's metrics and the parameters, and not the request tracing. Hence, this tab is expected to be empty. And that is the full loop. A batch arrives, gets pre-processed, trained, tracked, and surfaced on a dashboard, all logged at every step along the way.